In the last module, we talked about some basic game theory. A game requires three things: players, actions and information, and payoffs. We also talked about two keys to solving games: backward induction, which is starting at the end and working backwards, and second, paying close attention to the rules. Now, pivotal politics is largely about taking this game theory framework and applying it to the legislative process. We already covered a lot of the rules about this process in the lecture about the basics of American government, so let's put that to work with our new knowledge about game theory. First, who are the players? In pivotal politics, our players are politicians, but not just any politicians. We're interested in congressmen and senators and the president, and we could go further with this and think about courts and administrative agencies among a whole bunch of other political actors, but we're going to keep it basic. So when you think about pivotal politics and game theory, the first thing you think about is the men and women in Congress and the person in the White House. These are your players. Now, what do these players do? Politicians do lots of things. They give speeches, they raise money, they nominate students for military academies, they serve on committees, but most of all, they vote. And that's what we're interested in. How do politicians vote on a bill? They can vote for it, or they can vote against it. Now, when these people vote, what do they get? At the end of the game, they either pass the bill or they don't. So suppose if the bill passes, Congressman Smith gets a payoff of -5. And if Congress doesn't pass the bill, Smith gets a payoff of -20. Now, this is not a trick question. Do you think Smith wants the bill to pass or not? Well, of course, Congressman Smith wants the bill to pass because that gets a bigger payoff. -5 is greater than -20. And what can Smith do to help the bill pass? Vote for the bill! Figuring out the particular payoffs is a bit more complicated, so that's what we're going to work on in the rest of this module. Our players are members of the House and Senate, along with the President. The actions they can take are to vote for or against a bill, and their payoffs depend on whether or not the bill passes. To figure out the payoffs, we're going to think spatially. A lot of pivotal politics is basically dealing with points on a line. So here's a line. Let's say this line represents temperature. It's colder to the left and hotter to the right. And let's say Goldilocks likes her porridge just right. When it's served at this temperature, she loves it, and she gets this utility. But the hotter it gets, the less she likes it. Her utility falls and falls. When she tries Papa Bear's porridge, it's too hot, and she doesn't like it at all. In fact, she gets negative utility. The same thing happens when it gets too cold. Baby Bear's porridge is not very good either. Now, as the story goes, Mama Bear's porridge was just right, and Goldilocks got to eat it. But let's suppose that after eating Mama Bear's porridge, Goldilocks is still hungry, and she has to choose between the hot porridge and the cold porridge. Which will she choose? Now, this is a deeper question than you might think at first. Perhaps the most natural answer, and the answer we're going to stick with throughout the pivotal politics sequence, is that Goldilocks prefers the hot porridge because it's closer to her ideal temperature. One reason we may think this is if a degree hotter or colder away from the perfect temperature hurts just the same. So if the x-axis is the temperature and the y-axis is how much utility Goldilocks gets, we get a picture like this. This is the picture of Goldilocks' loss function. We call it a loss function because she is losing utility. That is, Goldilocks is worse off as the temperature moves away from her ideal point. It's a loss function because we can figure out Goldilocks' unique utility for any temperature. For example, if the porridge is this cold, the utility from the porridge is here. Just drop the line straight down from the point. Similarly, if the porridge is this hot, we can drop the line down to the loss function to figure out that utility. We get this tent shape for two reasons. First, we assume the loss function is symmetric. Making the porridge 5 degrees hotter than Goldilocks wants it is just as bad as making it 5 degrees colder. And second, the loss function is linear. That is, we have straight lines. And with linear loss, moving from 4 degrees to 5 degrees hotter is no better or worse than moving from 10 degrees to 11 degrees hotter. Now, obviously, you may think that these assumptions are a little bit silly sometimes. What's nice about this setup is that we can change these assumptions without too much trouble. Suppose we think that Goldilocks really doesn't like to get burned, so her utility falls faster when the porridge heats up than it does when it cools down. What does that do to the lines? See how the line on the right gets steeper? Now the pain Goldilocks feels is worse when the porridge is 5 degrees too hot than it is when it's 5 degrees too cold. See how the line on the right is longer than the line on the left? Let's go back to the symmetric picture for a second. We might also think that the farther away things get from the ideal, the worse it hurts. So making it 1 degree hotter is a little bad, but taking the porridge from 1 degree short of boiling to boiling is really bad. If things get worse faster, and faster is the key, the farther you get from the ideal policy, then the lines bend, like this. Now, for the purposes of this course, all you need to know to do pivotal politics is the picture of the tent with the straight lines. We're going to focus more on the institutional features of legislation, and to make things easier, we're going to assume that things are symmetric. But we really want you to know that in reality, politics doesn't have to be symmetric or linear, and the model can take that into account. If you have more questions on how to adjust these loss functions to better fit certain policies, feel free to ask your instructor. So let's go back to the plain old line and think about politics. Political scientists often use a line like this, or just a part of a line, say the interval from -1 to 1, to think about politics. Usually we think about progressives on the left and conservatives on the right. And this way of looking at politics is very useful and very flexible. Points on the line can be people or policies. So let's take an example of the minimum wage. To dramatically oversimplify the issues, conservatives think the minimum wage should be lower and progressives favor a higher minimum wage. If we put a higher minimum wage on the left and a lower minimum wage on the right, we can line up politicians and policies, congressmen and the minimum wage laws they favor on the same line. More progressive politicians and higher minimum wages are over on the left. More conservative politicians and lower minimum wage policies are on the right. Let's start by thinking about Senator Smith, who thinks the minimum wage should be $10 an hour. That point on the line at $10 is Smith's ideal policy for the minimum wage. Call it Smith's ideal point. So let me ask you this question. Suppose Senator Smith can't get a $10 minimum wage, but could vote for either a $9 minimum wage or a $12 wage. Which will Smith prefer? Let's draw the picture of the loss function and look at which Smith prefers. The vertical line is longer for the $12 than it is for the $9. Why is that? $9 is closer to $10 than $12 is, so Smith prefers the $9 minimum wage. Let's try another one. Suppose the current minimum wage is $8. Now Congress is going to vote on a bill to make the minimum wage $15. Will Smith vote for the bill? Now Congressman Smith thinks that the current minimum wage is too low and would like to see it go higher. But look at the picture of the loss function again. Smith prefers $8 to $15. 8 is closer to Smith's ideal point. And notice that the utility is higher at 8 than 15, and that's why. In this example, the current policy, the $8, is the status quo. The bill to raise the minimum wage is called the proposal. Since the status quo was closer to Congressman Smith than the proposal was, Smith votes against the bill. Pivotal politics is all about comparing the status quo, and we'll generally label the status quo with a Q, with the proposed bill that we'll usually label with a P. So now let me ask a slightly different question. How much of an increase in the minimum wage would Congressman Smith support? Well, how about an increase to $9? Well, of course, it's closer to $10 than $8 is. And how about to $10? Well, yeah, it's Smith's ideal policy. What about $13? No, that's too much. What about $11? Even though that's more than Congressman Smith wants, $11 is closer to $10 an hour than $8 is, so yeah, support it. What's the highest minimum wage that Smith would vote for? Well, let's look again at the picture of the loss function. The congressman gets this much utility from an $8 minimum wage. What other minimum wage gives Congressman Smith that much utility? If we cut over to the left, we hit the other side of the tent, and now we trace up to find the highest minimum wage that Congressman Smith would vote for, and that's $12 an hour. Notice that $8 and $12 give Congressman Smith the same utility, and when two options return the same utility to a player, we say that she is indifferent between the two policies. The shaded region here between $8 and $12 are all the minimum wage policies that Congressman Smith prefers to the $8 minimum wage. not indifferent, prefers. And Smith would vote for any proposal in this range. Let's review what we've covered in this module. We spent most of the time thinking about the payoffs a single player would get for voting for either a proposal or a status quo. Remember, the status quo is the law that is already in place. The proposal is the bill that Congress is considering that will change the law. We learned to think spatially so that players vote for the policy that is closer to their own ideal policy. We did all of this by learning how to draw pictures of the loss function, that tint, that determined the player's utility. We're now going to ask you to do a few easy problems based on this material, and then we'll take the next step to think about multiple players.